All right, let's take a look. Which one is number 1? Which one has an R of 1? No one?
Top right?
Yep. This one there. The third one on your sheet. Which one has an R of -1?
Second to last one.
Second to last one. Which one has an R of 0?
First one.
This one here?
No, bottom right.
The last one. Good. That leaves these two here as, are those positive or negative?
Positive.
Which one is more like a line, the first one or the second one?
Second one.
Second one. So that should be closer to 1.
Mm-hmm.
So is that one going to be 0.5 or 0.8?
0.8.
0.8. Does that make sense to folks?
Mm-hmm.
These two here are both negative, so those are going to be those two right there. Which one's more like a line? Second one. So which one is closer to -1?
Negative 0.08.
Negative 0.8. Yep. Good. All right. So this should be the easiest 4 points on the exam.
This is the stats with like a twist of like algebra.
Yeah, there's a little bit of other stuff. Right. Correlation coefficient. How do you find R? So it's this big long formula here. The neat thing is it's also, so so it's the sum of something, so when you add them up, divide by n-1, that's kind of like the average, right? It's kind of how we found the standard deviation. We took the average, sort of the average of them, we add things up, divide by n-1. It's kind of the average of what? What's x minus x bar over s? We've seen that before. Anyone?
Isn't that the
X minus x bar over s. No one?
Chapter 6 or something?
It's what it was from chapter 6. What'd you say?
central limit?
No. Z-scores.
Oh, z-score.
Yeah, this is how you find the z-scores. So for every value, like we had 63.0, we take that value, you subtract the mean, divide by the standard deviation. And then you take its corresponding one. So 63.0 matched up with 7.0 as the y. You find the z-score for the y, and then you multiply them together. You get for every point. You find the z-score for the x, z-score for the y, multiply them together, and then you kind of average them. You add them up, divide by n-1. That's another way of finding it. It's the same thing as that big formula up there. We're going to focus on that big formula up there. So let's take a look. Here is, so first of all, let's see what all these pieces are. So n is the number of pairs you have. The sum of x's, that's when you just add up all the x's. The sum of the x's squared, that's when you square all your x's first and then you add them. The sum of x in parentheses squared, that means you add up all the x's first and then you square that. And then the sum of the xy's, that means you multiply every x by its y, and you add up all those. R, again, is your linear correlation coefficient for your sample, and rho, I wouldn't say rho, is your linear correlation coefficient of your population.
Then spoon.
Yep. Exactly.
Yeah.
All right. So what we're going to do is we're going to help make our list, help us out here. So we're going to put cars into list 1 and our income into list 2. Everybody do that. Do it. So once we have them in there, you'll see what we need is we want every x multiplied by its y. So I want 63.0 multiplied by 7.0 and so forth. In L3, does anyone see where I'm below the L3? My cursor is? I'm going to arrow up. So my cursor is on the L3 itself. And I want list 1 times list 2. That's the times my y. So I'm going to do second L1. You'll see it pop in right there under list 1 at the very kind of the bottom of the screen. Times second L2. As soon as I hit enter, bam, it multiplies them all for me, which is super cool, right? If I wanted to get the sum of the x's squared, I could just do L1 times L1, L2 times L2, and I'd get all those. But we don't need all the individual pieces. All we need for this formula are the sums, are the totals. So there's actually an easy way of getting those totals. We're gonna do, does everyone remember when we did 1-bar stacks and people were like, well, when do we use 2-bar stacks? Right, and before we'd have just an x variable and we'd have like the probability of x, which is not a different variable. Now we actually have 2 different variables. We have an x, number of cars, and y, a separate variable, income. So this is 2-bar stats. So we're going to do, everyone do it with me, stat, calc, 2-bar stats. Hit enter. Now mine's a basic calculator, so I need to manually put in L1, comma above the 7, L2. For a lot of you, you'll have the fancier ones. So you put in L1 for your x, L2 for your y. Your frequency, leave that blank, completely blank. But I'm going to put in L1, comma, above the 7, second L2. Enter. And you'll see I get a whole bunch of stuff. There's my x bar, there's my sum of the x's squared. If I arrow down, hit the arrow down thing before I do anything else, all of a sudden you see all a bunch of other stuff, the y's and all sorts of other stuff in there. So I'm going to arrow up, and we're going to write in what all things we need. We need the sum of the x's, 153.8. We need the sum of the x's squared, 5859. As a quick comment, I'm going to round to 4 sig figs. That's plenty close enough. It is 5859.26, but if I were to multiply that by a number, any number like a large number or something like that, for example, that 0.26 would not affect things very much. The 5,000 affects things a lot more than the 26 cents does. So that means that in terms of error, it's really about the sig figs. It's not about the decimal place. It's about the sig figs. So you want to make sure you have at least 3 sig figs, and then things work out. So, for example, 0.0014. If I drop the 4, that makes a big difference. Like this is a lot different than 0.001. Because if I multiply this by a million later on, I end up getting multiplied by a million, 1, 2, 3, 1, 2, 3. It ended up being 1,400. Versus this, if I multiply by a million, it's only 1,000. And there's a big difference between 1,400 and 1,000 than there is between, if I multiply this by a million, it would be 5,900,000,000 something, and the 26 cents would only make a difference of, here, I'll show you what I'm talking about. Multiply that by a million. It'd be 5859. If the 0.40 was there, or the 26, sorry. Right, so the difference between those two numbers, that 260,000, doesn't make that much difference compared to the 5 trillion that's out there. So that's why the sig figs are the most important thing. Okay, back over to this. The y's. Let me arrow down to get my y's. 18.7. Sum of the y's is 80.67. And sum of the xy's is 682.8. All right. So now we're going to plug them into this. So my r is equal to, now what's my n? What's my n in this case?
6.
6, great. 6 times the sum of the xy's. That's 682.8. So you all are writing this with me, right? Multiply the sum of the x's. 153.8 times the sum of the y's. 18.7 over square root, and yours has it as 2 separate square roots, but you can combine them into one. It doesn't matter whether you multiply them and then square root them, or square root them first and then multiply them. You get the same thing. So here, I'm just going to leave them all as one big one. My n, which is 6 times the sum of the x's squared, 5859, minus the sum of the x's, 153.8, that amount squared, times, again, 6 times the sum of the y squareds, 80.67, minus the sum of the y's, 18.7, that amount squared. Okay. So, does everyone have this written down? Everyone find the green part. I'm going to break it up into just 3 parts here. Everyone find the green part. And I'll have you alternately either compute the red part or the blue part depending upon groups. Right, so again, that's to find those, you multiply 6 times this number minus that number squared. So let's see what folks got. So for the top part, what did I get for r on the top part? 122
0.74.
74. And then for the bottom part in red, what did you get for that?
11499.56.
What that's many nines. 1499.
11499.
11499.
Yeah.
156. Okay, sorry, my bad. And then what did folks get for the blue part?
134.33.
134.33.
Yeah.
Great. So now we're just going to take that part, and we're going to, again, when we calculate these, work from the inside out. So we're going to work with the inside square root first. So we're going to multiply 11499.56 times 134.33. Whoops. 0.33. Whoops. 134.33. And then hit enter. And then I'm going to square root that. So if you want to square root a number, it's the same thing as raising it to the 1/2 power. Not the 5th power, the 1/2 power. So I'm going to raise it to the 0.5 power. And that's going to be what we're going to divide by. So it's going to be 1220.74 divided by 124287. Here's the neat thing. I already have the 142.87 in my calculator. I want to divide by it. So if I want to divide by something, I can just raise it to the -1 power. And that would give me 1 over that. Does that make sense for folks? So, because like x to the -1 is 1 over x. So I'm just going to raise it to the -1 power because I'm lazy. You don't need to know how to do that. It's fine. If you don't want to do it, you can just do it the other way. And then multiply it by 0.1220.74. And you'll get 0.982. All good? That is our R. Now, here is it prettier, this is it prettier. And again, you end up with R of 0.982, which is a very strong positive relationship. I wanted us to go through one of those just so we had some practice with it and kind of could appreciate where it all came from. But we're going to stick with the simple way and just do linear regression t-test. So stat test, linear regression t-test. I'm going to go to my calculator. And my x's and y's, my x's are already in list 1, my y's are already in list 2. So I'm just going to do stat over to test. Is everyone with me? Stat test.
Yeah.
Arrow up, because it's towards the bottom. So arrow up to linear regression t-test, not interval, test. Hit enter. And again, my x's are in list 1, my y's are in list 2. Frequency, just leave that as 1. And then the greater than less than thing, you want not equal to. So for all chapter 10 and 11, it's always going to be equal to or not equal to. So this is always going to be not equal to as our H1. Leave reg EQ blank and hit calculate. So what you'll see is a whole bunch of stuff. I've got my p-value. Does anyone see my p-value? 484. Does that mean that I have a 484% chance?
No, there's an E -4 right there.
Yep. So anytime that p-value is larger than 1, you better have an E negative on the end. So my p-value, we're going to write down the p-value, 4.84, E -4, which means you write 4 zeros, and then your number, 484. And the decimal place goes after the first 0. If I arrow down, it also gives me these things called A and B. Write down A and B. Always going to have it write down A and B. A is 0.396. And B is 0.106. And then if we arrow down more all the way to the bottom, we get our R. 0.982, which is exactly what we got on our manual calculations. You'll also see this R squared. That's the percent of the data that we expect to match up pretty well with the line. All right, so then our R is 0.982, which is again is exactly what we got from our manual calculations, our painful manual calculations. Everybody feeling good with this? Mm-hmm. All right, so you're going to do your lin-reg t-test. While I'm here, let me show you one more thing that's useful. A lot of times we might need our y-bar and our x-bar. Our y-bar is our average y, and our x-bar, as we all know, is our average x. So we would do 2-bar stats. So again, stat calc 2-bar stats of L1, L2. Let's go ahead and grab those while we have them. Our x bar is 25.63. If I scroll down, I'll get my y bar 3.117. It's just good to have those pieces in there. All right, so you folks go ahead and do lab problem number 3. Come here. And while you're there, you write down you want your p-value and your R, you want your A and your B. And while you're there, sometimes it's useful to do stat calc 2-bar stats and get your x bar and your y bar. We'll talk about that later. So put this into list 1, X is in list 1, Y is in list 2. Do not do all the calculations we did with the sum of X's, sum of Y's. Don't do that. Just do linear regression t-test, lim-reg t-test to find your p-value, your R, your A, and your B. And then while you're there, do stat calc 2-bar stats of L1, comma L2 to find your X bar and your Y bar. And when you're done, take a break. All right, so what you all did was you put absences into list 1, and you put final grades into list 2. Start list 1, list 2, and then you did linear regression t-test, not interval. Some people mix those up on the exam as well. L1, L2, 1, and not equal to. So then you ended up with a p-value of, what was your p-value?
0.0014.
Great. And then your R was
0.94.
negative 0.944.
Yeah.
Great. And then you also had an A and a B. What was your A?
102.5.
And your B was negative.
3.62.
Great. And then while we're here, you also found a Y bar and an X bar. What was your Y bar or your X bar?
8.143.
That was your X bar?
Yeah.
8.14.
Yep.
And your Y bar was
73.
73. Okay, good. Everybody on board?
Do we need all that for like the credit? Or you just said the
We
p-value?
definitely need the first
The
four
first four?
things. The parts in blue you may or may not need. So
You still wanted those?
I do want them for today,
Okay.
and then we'll you'll be able to sort that out in the future. Okay. All right. So hypothesis testing. We have our null hypothesis. So we are in the middle of, we are at the top of page 77. The null hypothesis is always no something, H sub 0. So no something, in this case, no line. Is everybody on board? So it's not a line. And H naught is always, always, always equals, in this case, rho equals 0. Because 0 would be when it's not a line. Everybody on board? Right, so not a line, no correlation. H1 would be that rho is not equal to 0. In other words, it's close to 1 or negative 1. So it is a line. It's a line.
Yay.
There is a significant linear correlation. So again, H naught is, we don't reject that if our p-value is large. If our p-value is small, we would reject H naught, which supports H1, and then it would be a line. So here are our steps. Step 1, hypotheses. Step 2, write down your alpha. Step 3, find your R and your p-value from linear regression t-test, just like you did earlier, and then decide whether or not to reject H naught. So this is where you need to fill some stuff into the blanks. If the p-value is less than alpha, we're going to reject the H naught, which means it is a line. Right? That's what you write in the fill in this blank. Right? It is a line. There is a linear correlation. If we do not reject H naught, then it is not a line. There is no linear correlation. So if you look at this part here, it says, if we do not reject H naught, blank a line. It's not a line. Right? The knots should go together. If we do not reject H naught, it is not a line. And then finally, summarize for the claim of the variables. So if there's a claim, then we go just like it's been going in the past. If there isn't a claim, I'll show you what to do, because our examples today will not have a claim. So I will just demonstrate for you folks how to do that one right now. So first, state our hypotheses. We're doing this one together. The example in the middle of page 77, H naught, H sub 0, is that rho is equal to 0. Or you could write RHO is equal to 0. Either one of them is fine. H1 is that rho is not equal to 0. And again, you could spell out the rho if you like. Rho is not equal to 0. I don't care which one. But you better not give me P. That's big trouble because that's proportion. 2, write down your alpha. My alpha is 5%. Alpha equals 0.05. Step 3, compute your correlation coefficient, R and p-value. We did that earlier. So we did linear regression t-test of L1, L2, 1, and not equal to, and we ended up with a p-value of 0.000484 and an R of 0.982. This was the example we did first. So now we're going to make a decision about H naught. So everybody do the decision about H naught however you normally do the decision about H naught. So I'll give you folks 30 seconds with your neighbors to sort out step 4. So how to determine step 4? And as a quick reminder, on your exam, some people mess this up. Is this called, or what we're doing, is this called a hypothesis test or a claim test?
Hypothesis test.
Hypothesis test, because we're testing the hypothesis. We are testing H naught. So step 4 is all about whether or not we reject H naught or fail to reject H naught. H naught is on trial. We're testing H naught. So you have to actually say reject H naught or fail to reject H naught in step 4. You have to. Because again, that's what we're testing. We're testing H naught. Step 5 is summarizing for your claim. So I don't want to hear about H naught in step 5, and I don't want to hear about your claim in step 4. Step 4 is all about H naught. Step 5 is all about the claim. Okay, so let's go ahead and take a look. So step 4, what did we decide to do? What are we comparing?
The p-value to alpha.
P-value 0.000454. It is definitely less than alpha, so we're going to what?
Reject.
Reject. Reject what?
H.
H naught.
H naught. Don't forget H naught. You gotta say what you're rejecting. Which means that we have enough evidence,
That's 1.
and since there is no claim, does everyone see the fact that there's no claim? So if there's a claim, you just do it like you would normally do it. But since there's no claim, we would say, we're going to say enough evidence to say correlation between, what are my two variables?
Cars and income.
Yep, cars and income. Between blank and blank. Cars and income in this case. Alright, everyone feeling good with this? Go ahead and work. I'll give you a second to take a look at this. And then when you're done, I'll show you lab problem 4. Do lab problem 4 exactly the same way. Here's lab problem 4. And again, you're going to want to write down, give me your X bar. This one, you haven't done this one yet. We don't know what the R is or the p-value is, so you have to do that step. And while you're there, write in the X bar and the Y bar. Do that. Do the extra thing with the stat calc 2-bar stats, and give me the X bar and the Y bar as well.